Okay, so I'm just going to go ahead and go through each of the problems on your Unit 6 review, which is about rational expressions and rational equations and inequalities. So these first two problems, number 1 and 2, all it asks us to do is simplify. So in order to simplify most effectively, I'm going to go ahead and write everything in as factored of the form as it gets. So on the top over here, I have a 21, and then a squared is the same as a times a. And then on the bottom, I have a 21. And then a to the fourth is a times a times a times a. So the excluded values come from any a value that I could plug into the denominator that would make the denominator 0. So in this case, I just have a over and over and over again. And if I set a equal to 0, there's nothing to solve. But if I plugged a 0 in for a, that would give me a 0 in the denominator. So my excluded value on number 1 is 0. And then once I've done that, I can go ahead and cancel anything that cancels. So my 21s cancel, and then one of my a's cancel, and another one of my a's cancels. So I'm left with just a 1 on the top, and then a times a on the bottom, which is a squared. So this simplifies to 1 over a squared with an excluded value of 0. Same way to start on number 2, I want everything in factored form first. So on the top, I can pull out a greatest common factor, which is 5x. And then I'm left with x plus 1. And then on the bottom, I've got a factor doing my ACB method. So I need two numbers that multiply to 3 and add to 4, which is 3 and 1. So I have x plus 3 times x plus 1. Now that this is in factored form, I can go ahead and do my excluded values. So my excluded values are any x values that make the denominator 0. So if I plug a negative 3 in for x, negative 3 plus 3 is 0. So that's no good. And if I plug a negative 1 in for x, negative 1 plus 1 is 0. So that's no good. So those are my two excluded values. And then I just see if anything cancels. So I have an x plus 1 over x plus 1. Those cancel. And I'm just left with 5x over x plus 3. Now this x plus 3 is a factor all on its own, so I can't cancel these x's. So this is as simple as it gets. So this is my answer, and these are my excluded values. So then if we look down at numbers 3 and 4 is multiplying and dividing. So starting with multiplying, again, the easiest way to start is to put everything in as factored form as possible. So on the top here, I need two numbers that multiply to 15 and add to negative 8, which is negative 3 and negative 5. So the top factors to a minus 3 times a minus 5 over 2a times 1 over a minus 3. So with multiplying, I don't need a common denominator. I can just multiply right across the top. So on the top, I have a minus 3 times a minus 5 times 1, which doesn't change the value. And then on the bottom, I have 2a times a minus 3. So this 2a, if I plug a 0 in for a right here, that would give me 0 in the denominator, which I don't want. So one of my excluded values is 0. And then with my a minus 3, if I plug a 3 in for a, 3 minus 3 is 0, which I don't want. So those are my two excluded values. And then my a minus 3's cancel, and I'm just left with a minus 5 over 2a. Dividing is very similar to multiplying, but in order to multiply, I just have to switch my second fraction. So if I want to change this divide to a multiply, I'm going to move my 4 times x minus 9 to the top, and my 4 minus x to the bottom. And then I can do it the exact same way I did number 3. This one, conveniently, is already in factored form, so I don't have to factor anything like I did over here. I can just multiply straight across the top. So I have x minus 6 times x minus 4 times, so this got switched, times 4 times x minus 9, all over x minus 9. And then this 4 minus x isn't in standard form like we usually like it. To put it in standard form, I would put the negative x first and then add the 4. But we also don't ever like our x to be negative, so if I go ahead and factor out a negative 1, I have negative 1 times x minus 4. So I'm going to multiply this by negative 1 times x minus 4. That's a little bit more complicated than I expect you to remember, so there won't be one like that on your test, but we do generally like things in standard form. So now if I come to here, my excluded values come from this time, since I divide by this entire fraction, my excluded value comes from here, and this denominator. So from here, I get an excluded value of 9. And then here I get an excluded value of 9, but I already included that. Here I get an excluded value of 4, because 4 minus 4 would give me 0. So those are my two excluded values. Then my x minus 9's cancel, my x minus 4's cancel, and then I have a 4 and an x minus 6 left on the top. And then I divide that by negative 1. Well, dividing by negative 1 just makes my answer negative. So I end up with a negative 4 times x minus 6 with excluded values 9 and 4. 5 and 6 is the adding and subtracting section. These both happen to be subtracting, but the process is the same. So in order to add and subtract, I have to have a common denominator. So on this side, I have 12x to the third y squared, 12x to the third y squared. I do have a common denominator, so I can start right from subtracting. So I start by doing x minus x. Well, that's just 0. That cancels out. So then y minus a negative 5y, and minus a negative I'm adding, so y plus 5y is 6y over 12x cubed y squared. So then I can simplify this a little bit. So I have y squared is y times y. So one of these y's cancels with this y. And then 6 over 12, well, that simplifies to 1 over 2. So I have 1 over 2, and then I have x cubed. One of my y's cancels, so I just have 1y left. So this simplifies to 1 over 2x cubed y. Number 6 looks a little bit more complicated because my denominators aren't the same. So I'm going to go ahead and put this over 1 to remind myself that there is still a denominator here. And I got to find a common denominator. And in order to do that, I have to include everything from these denominators. So I have a 1, and then this 6x plus 6, I can factor out a 6, and I'm left with 6 times x plus 1. So it includes a 6 and an x plus 1. So I have a 6 and an x plus 1. And then if I multiply that by 1, it stays the same. So this is my common denominator. This side's already good. This side I've got to multiply by that whole thing. So 6 times x plus 1. And multiply the top by 6 times x plus 1. So I'm going to go ahead and multiply these first back together. So this is 6x plus 6. I'm going to multiply that by 4. So 6x times 4 is 24x. 6 times 4 is 24 over 6 times x plus 1 minus x minus 1 over 6 times x plus 1 again. So then I can go ahead and subtract straight across. So 24x minus x is 23x. 24 minus a negative 1 is like 24 plus 1, which is 25, over 6 times x plus 1. And at this point, there's nothing to factor, nothing that cancels, so I'm just done right there. Numbers 7 and 8 are where we finally get to actually solve the rational equation. So in order to do that, just like when we're adding and subtracting above, I have to have a common denominator. So if I look here, I know my common denominator has to have a 6n squared, and then it has to have a 3, but 3 goes into 6, and it has to have an n, but it already has an n. So this is my common denominator. This side is ready to go. 3n, if I need to multiply that to get 6n squared, I'm going to have to multiply it by a 2, which would give me to 6n, and then a 2n would get me to 6n squared. So I'm going to multiply by 2n and 2n. So now this side I can add straight across because these are already the same. So I have 1 plus n plus 1. So I have an n, and then 1 plus 1 is 2 over 6n squared. And then this side is equal to 1 times 2n is 2n. 3n times 2n is 6n squared. So now that my denominators are the same, they're going to just end up canceling out, because if I multiply both sides by 6n squared, these cancel. So I just have n plus 2 equals 2n. So I need to get all the n's on the same side. So I'm going to minus an n for both sides. So now I have 2 equals 2n minus just 1n is just 1n. So 2 equals n, or n equals 2. And if I plug a 2 back into my denominator here, 2 squared is 4. 4 times 6 is 24, so that doesn't give me 0. Or 3 times 2 is 6, that doesn't give me 0, so I'm good. My answer's not considered an extraneous solution. This side, exact same thing as I did over here. I've got to find a common denominator for all three of these. So I know it's going to need an x squared, and it's going to need a 2, but it already has the x squared, it already has the 2, already has an x. So this is my common denominator. So this one's already good. This one's missing one of my x's, so I'm going to multiply by x over x. And then this side's missing the 2, so I'm going to multiply by 2 over 2. So I have 2 times 2 is 4 over 2x squared equals 1 over 2x squared plus 1 times x is x over 2x squared. So all my denominators are the same. If I just multiply both sides by that, they're going to cancel out. So I have 4 equals 1 plus x. So then if I minus a 1 from both sides, these cancel. 4 minus 1 is 3 equals x, or x equals 3. So that is all the types of problems from 6.1, 6.2, and 6.3. There's no review problems on here from 6.4 since we just barely did that yesterday and today. So I'm going to go ahead and show you one problem from that homework assignment in case you're struggling with solving rational inequalities. So we'll just do number 13, the very first one. So the first thing I have to do is find my critical values, which I do by setting the numerator and the denominator equal to 0. Some of you are pretty good at doing this in your head, which is fine, but if you struggle doing it in your head, you can go ahead and do it by hand. So when I set x plus 3 equal to 0, I get x equals negative 3. And when I set x minus 1 equal to 0, I get x equals 1. So negative 3 and 1 are my critical values. So I need to plot those on a number line. But I've got to figure out if it should be an open circle or a closed circle. So anything I get from the denominator, I can never divide by 0, so it's always an open circle, which means it's not included. And then the numerator, it depends on this sign. So if this has an equal sign with it, then it's included. It's a closed circle. So this is a closed circle. But if it was like this and it didn't have the equal sign, then that would be an open circle also. And then at this point, I need to test each of these three intervals. So I've got to plug in a number from here, here, and here. So I'll start with over here. So I need a number less than negative 3, so I'll just do negative 4. So negative 4 plus 3 is a negative 1. And then a negative 4 minus 1 is a negative 5. And a negative divided by a negative is a positive. So numbers over here give me a positive solution. And then if I repeat that with another number from in this section, I'll pick 0. 0 plus 3 is 3. 0 minus 1 is a negative 1. So 3 divided by a negative 1 is a negative 3, or a negative number. And then I just do that one more time with my last interval, so something bigger than 1. I'll do 2. 2 plus 3 is 5. 2 minus 1 is 1. So 5 over 1 is just 5, which is a positive solution. So now I need to look to see if I'm graphing where the positive is or where the negative is. So I come do that by looking at this sign. It says I'm looking for things that are greater than or equal to 0. Well, if I'm thinking positive and negative numbers, positive numbers are greater than 0. So I'm looking for where my solutions were positive, which was right here on this side and right here on this side. So at this point, I can go ahead and just state those two intervals using interval notation. So this part goes from negative infinity to negative 3, and the negative 3 I'm going to use a bracket since it's a closed circle, versus this side goes from 1 to infinity, and I use a parenthesis because this was an open circle. And that's all that we did this unit. So hopefully that helps you prepare a little bit for your test.